Hello, I'd like to cover some of the other things you can do with the Joule theory. You've all seen it as a boost converter driving an LED, but with just a diode added to the output side, it can function as a general purpose one. Like this. I built the circuit and I thought I'd show it to you in operation. Now here we see the transistor switching, and I just get my probes in place. Put all my channels on. Now here we see I made these current shunts, so I can measure the input and output currents, and also I'm measuring the input and output voltages. And you can't see it so clearly on the screen, but the input voltage is approximately 1 volt, and the input current is 29 milliamps. And we also have an output voltage of 3.3 volts and output current of 6 milliamps. It's not very impressive, but we'll have to do for today. And this works very well as long as the output voltage is higher than the input. But if the output is lower, then it usually stops oscillating and the transistor ends up in a half-open state, and that wastes a lot of power. So what we can do to solve this, if we sometimes need an output that is lower than the input, is we reconfigure it into a buck boost configuration. And we do this by simply taking the negative of the output and connecting it to the positive of the input. And I'll try to reconfigure this a bit quickly to show you the output crossing the input. For that, instead of a battery, I'm going to be charging a capacitor. So I paused the video for a while because it seems when I'm filming I can't remember what I'm doing. So I reconfigured it into a buck boost configuration, and I'll show you how the output voltage can cross the input voltage. There you go, no problem. Now one of the problems with this configuration, see here, is this, we get this weird circuit where the negative of our output is connected to the positive of our input. So we don't have a common positive, nor do we have a common negative. And the way to solve this problem, well, I'll solve it later, but for now I will show you the buck converter, which we can use if our output is always lower than our input. This is the circuit with an NPN transistor. You can see we have common positives, and then we switch on the negative side. Now if we want a common ground instead, we'll use a PNP transistor and we'll reverse all these components. Now we have a common ground for a circuit. Often we want this. And I'll pause the video again to build this final circuit, and I'll see you soon. Alright, here we see our buck converter in action, so we know it works. And remember I said that the buck boost converter earlier would invert the input and outputs. And we have the solution for this. I just use a separate output winding. Of course the problem here is that we need more wire, and if we want really high efficiency we may not fit as much wire as we want into our ferrite. You see my ferrite is already stuffed, so I'm going to leave this final circuit as an exercise to the viewer.